Hello, I'm Al Karitz. I'm the Service and Applications Manager at Electron Microscopy Sciences, talking to you from our Microscopy Academy at our main campus in Hatfield, Pennsylvania. Today I'm going to talk about the basic setup and operation of our Lynx tissue processor. On the back of the Lynx unit we have the power switch, the power input for your line cord, which goes to, in this case, 115 volts, typical US current. We have a slot for a memory stick, a USB port, more on that later, just so you know where it goes. The external alarm input, the battery power switch turns the battery power on and off, the cooling fan for the unit, and the exhaust line, which typically goes to a hood unless you put the entire unit inside of a fume hood. This is the backup battery tray. It's nickel cadmium batteries. Perhaps needs to be replaced every year or two. It is just enough power to allow your samples to go to a safe position if the system loses power. Okay, so once everything's connected up and out of the box, first thing you do is release the handle and open the lid. Once the lid is open, you can see the Vial Seal assembly. This is mounted so it can go up and down and will close your reagent vials to air, reducing the influx of water vapor into your solvents and solutions. Also reduce the evaporation. Once the lid is open, you can raise the sample arm assembly by just pressing the up arrow. Once the arm is up, you can remove the carousel by undoing the screw and lifting up on the carousel. The carousel arrives all backed up, all by itself. From there you have to insert these aluminum vials. The aluminum vials act as a heat conductor for the two heating and cooling stations on the bottom of the chamber. These aluminum vials have what we call a rubber bumper on it and is inserted through the hole in the carousel, locking it into place. Once all the stations are filled that you would like, for instance, we're only using 18 steps in our EM process here, but you have the flexibility of using all 24. So once that is done, you replace the carousel. It's indexed so you can't possibly get it wrong. You install the screw. Once you have all the aluminum vials in place, you have these disposable plastic vials which are graduated on the side. It's a little tough to see, but they are graduated. The maximum amount of reagent that you should use at any given time is 18 ml, and this is dependent on the number of samples you are processing that particular day. So the maximum is 18. Realistically, I think the minimum is probably about 8 ml. So once you have the vial, you need to insert it in the processing stations, and that is just simply done by pushing it down all the way. Notice I've got my hand on the center. I'm just going to load 5 for now. These vials are disposable. However, you can reuse the vials that are used for buffers or dehydrating agents, but you should dispose of them if they've been used for any fixatives, osmium, any resin containing solutions. Those should be tossed out at the end of the run. This will minimize your turnover in vials. You'll at least be able to reuse many of the vials per run. Now, sometimes the vials are rather stubborn to get in on the bumper. The bumper is to prevent the vial from sticking to the sample arm assembly. We'll talk more about that in a minute. What I recommend is you get a little Dow Corning vacuum grease and put a very small amount on the rubber bumper, just coating the front surface, and this will allow it to slide very easily. Okay, now let's talk about the main control panel. It has a keypad, a number of buttons. It's a very easy system to program and to run. There's a group of 3 main buttons over here. Run, which runs the program, and you press run, then select the program you want to run. Program allows you to program a new program in the system. Review allows you to review a previously entered program that happens to be in the system. Clear clears whatever you've entered or any error. Enter button is just simply that. It enters whatever function that you inputted. SVC is service mode, which is not password protected, and you shouldn't go in there without instructions from myself. Stop is just that, stops whatever or cancels whatever process is in motion. When you turn the system on, it comes up in standby mode, does a battery and software check, etc., etc. Utility is for setting passwords, then the clock and the amount of backlighting for the screen. These up and down arrow keys are always active. It allows you to lower and raise the sample arm. So let's have a look and see what programs are in here. 02, let's see what that is. Okay. It comes up and it tells you reviewing program 2. The program type is EM. Now this system is also capable of small quantity histology process. That would be designated by HP. Not everybody buys the histology option. Some people just buy the histology option. Just be aware that it's available. Now it prompts you to do everything. The software is very intuitive. You really can't make too many mistakes. It won't let you. It tells you exactly what you need to do. So enter to continue, stop to exit. So we're going to press enter. So now it comes up with various information. At the top of the screen, it says what station we're programming, the time at the station, that's 15 minutes and 0 hours. The temperature is 20 degrees. AV is for agitation and vacuum. When we get to a programming step, more information about those. The important thing is it says up arrow for modify step, down arrow for the next step, exit to exit review, you press stop. So let's go ahead and let's look at the next step on this program. Station 2, Station 3 is for an hour. It's probably osmium. 10 minutes is probably a rinse. And it goes on and on. If you're happy with it, you can press exit. So it goes back to standby mode. Okay, so let's create a quick program here, just so you can see how it's done. So you press program, enter program number, let's just say program 6, enter. Okay. It doesn't exist. So now it gives you the choice of whether you want to make an EM program or a histoprocess program. In this case, we want to press 1, which is a type of EM program. Press enter to continue. So, program 6, station 1, station time. This is in minutes, this is in seconds. So you just enter 10, that's 10 minutes. If you make a mistake, you just press 0 till it zeroes out again, and then you can enter what you want. Hit enter to enter that station time. Temperature. The system will operate between 4 degrees Celsius and 65 degrees Celsius. It tells you right on the screen what the parameters it will accept. Most people run at room temperature, but some people like to do certain steps at a different temperature. Sometimes it's advantageous to run the resin steps at a little bit of elevated temperature, just so the viscosity lessens a little bit. But we're just going to accept the default, which is 20. So now you get to select agitation and vacuum. So you have the options of no vacuum or agitation, vacuum only, agitation only, or both vacuum and agitation. So in this case, let's press 4. I'm sorry, 3. Vacuum and agitation, press enter. And you notice how there was no 4, so it just sat there and didn't accept the input. So station 1, review comes up. Station 1, 1 minute, 20 degrees, agitation and vacuum. If you entered something wrong and you want to change it, you press the up arrow, and then this little asterisk appears. You can change the time, temperature, or agitation vacuum value. It just scrolls through until you want to select the one that you want. So let's change the time. So let's give it 2 minutes, and then you like that, so you can go to the next step. So now it says station 2. You enter the time, 2 minutes, enter. Temperature, we'll use default. Agitation and vacuum, 3, enter. Okay, so after you enter all your steps, and I recommend that you use the protocol that you've been using for your hand processing at the bench. This way it will closely mimic, but in a more precise fashion, your hand processing method. There should be no difference in the quality of the results at the end. You could even increase it a little bit, or you could decrease it or increase the number of steps, add extra infiltration steps or extra dehydration, or add a urinal acetate block stain or something to that effect. Whatever you want to do, but start off with your original program that you do at the bench by hand, and enter that in the system. When you're done entering that program, you press stop, as it says, to save program. It says saving program, and now you have it. So now we want to run a program, and that was program 6. Press enter. It tells you what program it is. Now the title isn't added. There's a little bit of software, a simple program that we wrote that will allow you to make the program on your benchtop computer. I can send you that. It's normally not included because it isn't well documented, nor is it really supported. But if you want it, you can do it. And this way, it'll say what the title of the program is. It'll also say what reagent it is and how much. Speaking of such, I recommend that you put a little piece of tape on the carousel and label what station is, if you're going to run that station around continuously. This way you don't have to reference what station 5 is ethanol. You can just say on a little piece of tape, ethanol 50%, whatever. So now we can press enter to select it. We're in run mode. Now this system can either start this particular process now, or you can wait and delay the start of the process for up to 99 hours. So if you wanted to run the processor overnight, so it's ready to throw into blocks, you can do that. However, it's always best to run it during the day while people are around in case you have an issue. So we're going to begin the run now. I'm going to press enter to start this. You can also start at any station within the program. Press clear to alter station, press enter to start program. The default is starting at station 1, but if you had something that was prefixed or whatever the situation is, you could start at 3, for instance, or wherever you wanted to start. It's completely flexible. So we're going to press enter. So now it does a battery test. And we'll run the carousel around to find home. Meanwhile, you come over with your processing stick with your samples in buffer. It finds number 1. Now the display says load tissues, load tissue sample, and press down arrow. So what we're going to do is we're going to hang the stick from underneath. Now I've added these O-rings. This will keep the stick from tipping too much in one direction or another. It just hangs underneath there, and you press the down key to start your process. You don't want to hang your samples out in the air while the carousel is finding its home station for 2 reasons. 1, you know, your samples are dripping all over the place. 2, you could potentially air dry the surface of the tissue. So that's why this program step comes and stops after it indexed and said load your samples, press the down arrow. So now the process is underway. We can see here on the display that we're program 6. We're at station 1, vacuum mix, 20 degrees for 2 minutes. This is the time at that station, decrementing down to 0. This is the total time of your process, so you can estimate how long it will run, or set an alarm on your cell phone or whatever. So it's 3 minutes and 3 seconds right now. This is temperature at station 2, 19 degrees. This is temperature at station 1 at 20 degrees. So we have 2 independent temperature controls that we can take advantage of. This is T1, this is T2. So you can pre-cool or preheat your reagent before the sample gets there. So it has another 20 seconds at this station. Now, I have customers that will run this particular system on the benchtop with osmium. There's a fume evacuation system that pulls a negative pressure when you have the lid closed. So now it's going to the next station. However, your safety people may not like that, so I recommend that you use the system inside of a fume hood. This way there's no question that everyone will be safe, and if you spill osmium in the fume hood, it's all contained. If you spill osmium, if this is sitting on a cart or a bench top, then you have to really sort of evacuate the lab. So I recommend this gets run inside of a proper fume hood. If you decide that you need to stop the machine for any reason, press stop. It will release the vacuum if it does this automatically, whether you're using vacuum or not. So you'll have to wait a certain number of seconds. Okay, so first thing it tells you to do is lift the cover, because you cannot open the cover if the arm is in the up position. You can raise your sample arm and do whatever you need to add specimens. When you're ready to resume, or whatever you had to do is taken care of, you can either press the down arrow and it will resume the program where it left off, or you can press the stop button 3 times and it will exit the program. It's perfectly normal for the system's vacuum pump to stop periodically. Usually it will stop when the vacuum inside the vial reaches the set point of the device that reads the vacuum level in the system. So don't worry about seeing that or hearing it stop. Now at the end of the process, it's decorating. It's got like 12 seconds left in the process. It will just stop and leave your sample in the last reagent and say run complete on the screen. I'd like to discuss some of the other menus available to the user on the Lynx 2 processor, just for an overview of what's useful and what you really should stay away from, unless you're talking to a service guy. First, the utility menu. where you can adjust the contrast, adjust the clock. You can look at summaries of events. You can scroll through them, but it's really sort of in code, not very useful to you guys. Programs is the utility for exporting and importing programs. I highly recommend you export your programs to a thumb drive. I showed you the port on the back. This will prevent the loss of programs and protocols due to unintentional individuals messing around with the machine, as well as failures of the computer. It's quite simple, like all the other instruction. Press 1 to export, press 2 to import. Not real rocket science here. The thing you should know is you should have a thumb drive smaller than 1 gigabyte. Thumb drives over 1 gigabyte don't talk to this machine very well. That's the only stipulation. Agitation is the only other important one that you might want to work with. I've got my machine set to medium agitation, and you have the ability to move it and select low, medium, or high. Default is medium. Again, you can see me pushing the stop button to back out of any of the menus. Now let's look at the service menu. We have motion, which controls the spinning of the carousel and alignment, as well as the up and down arm. The lid seal, all some things that you should perhaps stay out of. Temperature, you can view temperatures or adjust offset. There's no reason to go into this menu. Either inputs and outputs, accessories, USB test and battery tests. Well, not very often. The machine does a battery test every time it starts a run and when you first turn it on. Password, you can change this to keep people from accessing the machine who are not authorized to. It's a good idea. If you change the password, you will need to be around if you ever need service or send it in for service. I'm sure there's a backdoor password, but the engineering people haven't given it to me because I haven't needed it or asked for it. And that's an overview of the auxiliary menus on the Lynx 2 processor. Okay, I have here a variety of baskets that are available to put your samples in, as well as the loading and unloading jig. So I will get an example of each. Okay, I used to do clinical EM at the Yale School of Medicine many years ago, when the residents and attendings were using large bore needles to do biopsies of kidneys and liver and stuff. And nowadays they've gotten much smaller, so we have a problem of maybe a small piece finding its way out of a sample container. This is our 3-segment basket, which will allow you to do 3 different samples in one basket. We cannot make the holes smaller than you see here, because then you have a problem of getting flow through the basket to refresh the reagent, as well as drain the reagent when you're exchanging samples. Here we have a 4-segment basket, same arrangement. If you're doing renal biopsies, this is perhaps your best choice. This is an 8-segment basket, and it has the smallest holes of all the baskets available. So regardless, you have to load your samples on the jig here. First, let me talk about the sample rod. This is it's called the vial stem assembly, or you can call it a sample rod. This is the device that holds the samples. The rod has a T portion which attaches to the sample arm. I'll show you that a little later. It has a disc at the top. The purpose of this disc, which is the lids for the baskets, is to break any bubbles of resin that climb the rod during vacuum infiltration. I recommend that you degas your resin in a small vacuum chamber after you make it. This reduces the bubbling effect. One of the problems is the spread of resin to the sample arm gasket. That has to be kept meticulously clean. More on that later. Otherwise, things get really gummed up fast. So that's what that disc is for. You'll see a number of different holes on the rod as well as a threaded part. You put one of these cotter pins at the level that you're going to use for that bunch of samples for the day. It might become standardized in your lab that you're going to run X number of samples or only this kind of basket. Depending on the stack of sample baskets, and you can mix and match them, that's not a problem. This will determine the level of the cotter pin. So you first need to have a basket, and it's easier to do this before you have all your samples on it. Do it while the rod is dry. All I'm doing is stacking up an appropriate number of baskets and lids. Don't forget the lids, otherwise your samples will get out. And then we screw on the star on the bottom, which screws and tightens it. So that arrangement right there with the 8-segment baskets, 8 times 3, that's 24 samples that we're going to run in this test run, so to speak. Okay, so once you've determined the proper placement of the cotter pin on the rod, you can unscrew this. An important thing that was sort of discovered by accident, this is stainless steel, so is this. It's chromium plated. We found if people if you're going to process with osmium on the system, or at least having your samples mounted on the stick in a vial with your osmium if you so desire, if you dilute your osmium in DI water, it does eat the threads on the inside of here and on the outside of there and chews them up, so they sort of crumble and fall off. This can be alleviated by using just plain glass distilled water to dilute your osmium. And we found this out when the system first came out in early 2000s, that people were using DI water instead of distilled water, because this part has been around for 20 years. It was part of our Lynx 1 system, which there were thousands of the processors out, and we never saw this problem until people started switching over to DI water. Okay, so this is the loading jig. The loading jig has little index pins that you put your baskets on, and all the baskets have a chart, so you can match the chart with the basket and put the specimen details in. In this way, you have a permanent record of that particular run in the processor. And there's another chart for the other 4 and 3 segment baskets as well. So what you do is you put a little bit of buffer or whatever the reagent is that your sample is in. Of course, we don't want to put osmium on that, but either you can do it in fixative or in your first rinse buffer. You pour some rinse buffer into here, and then you can put your samples in there that you wish to process for that particular patient. You take the samples and you put it in the appropriate position according to our chart. Once the samples are inside, you put one of the covers in place and you push the stack on the rod. Put the samples in place on the next one, and there's a little bit of buffer in here so it doesn't hurt to leave it right there. You make the next stack. Put the samples in that particular carrier. Oops, those are a little loose. And you make the next stack. Okay, and once you have the stack, you screw the little star in place and tighten it up, and then just drop it in a small container of whatever the reagent was. Now, let me show you what this was intended for, but I find that it's a bit cumbersome. You can use that to screw on the star also. That's what it was designed for. However, some people like to do it by their hands. So once your sample loading is complete, it's time to go put it on the processor. Okay, after you run the processor and your samples are taken off, you should pull out the vials and dispose of the reagent. What I usually like to do is I like to put the caps on the vials and remove them that way. There's no spillage, because it can be a little bit tricky to get them out. If you want to take them out of the machine and do it on a bench top, you can just remove this and set it on some sort of flat pedestal like this little ice tray, and that will act as a stable platform underneath. What I usually do after every run, and I think this is sort of a mandatory thing, is take a Phillips screwdriver and you undo the screw which mounts it to the machine. You disconnect the vacuum line and Here you can see the neoprene rubber seal that we use for sealing the vial, so there's a vacuum could be drawn. The vials have a lip on it which presses against the seal assembly like so, and allows vacuum to be produced inside the chamber. This is the vacuum pump. I'll show you that in operation a little later. This is the hook that the samples get held onto. Now, after every run, you need to remove this, take it to the fume hood if it's not already in there, and clean this neoprene with acetone till it's no longer sticky. 99% of the problems that people have are caused by not cleaning the machine properly after use. It takes approximately 10 minutes. You should work that into the schedule. So after you clean it, you can reinstall it in the machine. Now, depending on what you do with the machine, whether you run osmium with it, we recommend that you make a good assessment of it every 3 months and replace as needed. This is just the peel and stick. I'm not going to unpeel it, but if you pull it, it comes off. Once it's off, you take some acetone, remove any residual sticky glue that holds this on. You peel the paper off of the replacement part and you just line it up and stick it in place. It's that simple. Add some pressure and then go ahead and replace it on the machine. If you find any resin drips in particular on the carousel, you need to remove the whole vial, aluminum vial, and clean the vial underneath the lip here as well as around here. Occasionally epoxy will drip down below, especially if you overfill the vial by accident. It creates a sticky mess. All that needs to be thoroughly cleaned with acetone, although a lot of times it's best just to let it polymerize and then use a razor blade to pop it off the surface. Every 3 months you need to assess your vacuum pump line. This is regular maintenance that needs to be done. To replace it, you just disconnect the main vacuum line and you just simply pull it out of its holder, undo it from the peristaltic pump, and then to reinstall you just reverse it. This will not start on its own accord, so don't worry about it. It's that simple. Give it a couple of spins and you're good to go. And that's how you operate and maintain the EMS Lynx 2 tissue processor. If you have any questions, feel free to contact me at the email address and numbers below. Thanks very much for your attention.